hot. Hey guys, welcome to my garage. Sorry I can't be in class with you guys, but I've got a sick daughter at home, so I have to take all the precautions necessary. And we had to go get her COVID test today, so I can't come back until we get the test results. I want to show you guys a quick little test that I've kind of drawn up. We're talking about glass fractures, and we're talking about glass analysis. And so I'm going to shoot a couple of arrows through a couple of panes of glass that I have, and I'm going to see how different arrow speeds cause different fractures. And so what I have is I have two different bows here. I have a compound bow that I use for hunting, which should shoot arrows right at about 315 feet per second. Some of the heavier arrows are going to be right at 300 feet per second. And then this more traditional recurve bow should be shooting arrows right at about 200 to 220 feet per second. So how I'm going to set this up is I'm just going to be shooting here in my garage, so just here from about 5 feet. But I'm going to take the back side of this glass and I'm going to put duct tape on the back side of it, so that way the glass fragments won't go everywhere if the glass does shatter pretty dramatically. And then I can also take that and it can still be intact, where I can measure out to see, does a faster bow produce a larger concentric ring, or would a faster bow produce a smaller concentric fracture ring? So let me set up the test and I'll keep going. Alright, so these things didn't come out half as ugly as I thought that they were going to. What I'm going to do is I'm going to shoot the side with the glass exposed and have the duct tape side towards the back, just to see how they react. Let's also talk about variables. I'm going to use the same arrow for both shots, just because, you know, if I'm using regular hunting arrows out of the compound bow and I use different arrows out of these, they're going to have different diameters, different weights, and all sorts of different variables. So I'm just going to keep the arrow the same, just so hopefully I can replicate as close to the same results as possible, with the biggest variable just being the speed. Same distance for each one. Again, I probably have from here to my toolbox is probably 7 feet. So that's it. Let's get this set up. Let's see. I really hope this works, because that would be a lot of fun. I hope I don't screw up on my end. Alright, first up is going to be the recurve bow. Let's see. I don't want to shoot it too low because I've got wood back there. Let's see how this goes. Oh. Alright, not bad. I think I just barely cleared that wood, but that's a pretty good fracture there. Let's see if we can get in on that. Yeah, there we go. That's not bad. It's a pretty decent little fracture. Kind of a lot of stuff that I was expecting to happen. I'm really glad that a lot of the glass kind of stayed intact, so that way I can look at it. But cool. Alright, let's do the compound bow. Compound bow up. Shooting a weird little arrow out of this one. Let's see. Ooh, that looks a lot smaller. Yeah, that one looks a lot more compact. Cool. This one went straight through the duct tape, where the other one, it seemed to kind of split the duct tape a little bit. Let me get a measure on these fractures, and yeah, then we'll talk through the analysis at the end. Okay, so here are the results, and it's interesting that you would figure that the faster compound bow would produce wider concentric fractures, while the slower compound bow would have smaller ones. But that's not what we're seeing here. What I'm seeing here with the compound bow is I have a diameter from the outside ring of the concentric fractures right at about 1.5 inches, while the recurve bow actually had a wider concentric fracture at 2 3/4 inch. And so why would that be? Why would it be that the faster bow would produce, or the faster arrow would produce a much smaller hole? And I think that answer for that is the momentum of the arrow that's going through. It's not bending that glass before it fractures, which is what you're seeing with a wider concentric fracture on the recurve bow. But we're really only looking at about 100 feet per second difference, which is pretty big in the world of archery. But yeah, anyways, so nice little easy at-home experiment. Didn't take up that much resources, didn't take up that much time. I hope you guys enjoyed, and I hope you guys have a great rest of your day.